Hello, this is lesson 10B, Theoretical versus Experimental Probability. If you need this handout, you can find it on my PowerSchool website where you would find this video. And please have different colored pens available before we begin. Press pause if you need to gather your materials first. Please pause now. Okay, so the first thing we're going to look at is the difference between theoretical probability and experimental probability. So on this table on the left side we have theoretical probability. So theoretical probability is when all possible outcomes are possible. And it is also what is expected to happen. And then we have experimental probability. Experimental probability is based on repeated trials, and it is what actually happens. So theoretical probability is what should happen in theory, and then experimental is what actually happens when we do an experiment on it. Okay, so let's take a look at problem number 1. It says, in the table below, a number cube is rolled 50 times. Find the experimental probability of rolling a prime number. And here I have a picture of the table of the experiment performed. I know it's really hard to see because it's super tiny on your paper, but I can zoom in so we can see it on the screen here. And a prime number, first we need to know what a prime number means. Prime number is a number that's only divisible by 1 and itself. Okay, so the prime numbers, the smallest prime number would be 2. Okay, 3 is a prime number, 5 is a prime number, and then for a number cube, that's it, because the next prime number is 7, and that's not on a prime number. So when we're looking at this graph, okay, if you look at the screen here, a 2 is rolled 4 times, okay, and then we look at the next prime number. A 3 was rolled 8 times, and then a 5, the last prime number, a 5 was rolled, we're going to say 11 times. So we're going to add the total here. Okay, so again, the 2 was rolled 4 times, the 3 was rolled 8, and then we have 11 for the 5. So when we add them together, we're going to have a total of 23. Okay, so a prime number was rolled 23 times, and the table shows that in total they rolled it 50 times. So our probability of rolling a prime, let's go ahead and write that correctly. Okay, so the probability of rolling a prime, okay, in simplest form is going to be 23 out of 50. Okay, so that's our experimental probability based on what our experiment says. Okay, now we're going to use the experiment above to predict. Let's do problem 2. We're going to use the experiment above to predict how many times a 4 will be rolled if the cube is rolled 200 times. So using our experimental probability, okay, based on what happened the first 50 times, when you look again at that 4, again I'm zooming in, look at the 4. On the 4 it was rolled 11 times, okay, and it was rolled 11 times out of 50. So we're going to write that as our first fraction, 11 out of 50. And let's say we were to roll it 200 times. Based on these results, we're going to write a proportion here. We're going to put 200 on the bottom. We're going to see how many times would we expect the 4 to be rolled. So we're going to solve this proportion, and you can do the butterfly if you want, okay, and then solve for x. Or if you can work across, which I like to do, I like to do that. 50 times 4, that's 200. So 11 times 4 will be my x. So we could expect that a 4 would be rolled 44 times. Okay, and let's label that times. Okay, let's box our answer. Okay, let's look at problem number 3. It says here, an experiment was done where marbles of equal size were chosen, one marble at a time at random. The results of the experiment are shown. Okay, so we have our marble color and how many times they were picked. Part A, how many times did they pick marbles? So what we would do to figure out the total number of times they picked marbles is we would add the outcomes together. I know there's a lot of room to list our numbers, but let's add 15, 28, 47. Let's squeeze it in there. And here we're going to have 20, carry the 2, 3, 4, 5, 6, 90. Okay, so they picked marbles 90 times. Okay, we just added them together. All right, so now that we have the total of times that they picked marbles, let's look at part B. Part B, the question is, if they were to continue picking marbles at random 180 times total, based on the outcomes above, how many blue marbles would they expect to pick? Okay, so we know that in our experiment, blue marbles were picked 15 out of the 90 times. So we're going to use that as our first ratio, 15 to 90. Okay, now we're going to set it equal to, okay, and we want to know if they were to perform it 180 times, picking marbles, we're going to put x over 180. And again, you can do cross products or you can work your way across. 90 times 2 is 180. So 15 times 2 is x. So we would expect that they would pick, let's see, 30 blue marbles. Okay, so go ahead and write that and box your answer. Okay, so now is a good time for a secret code word. What I want you to do is to write your favorite color next to this problem right here. And if you don't have a favorite color, you can pick blue, because blue is my favorite color, or just pick any color that you'd like. Okay, and now let's continue to part C. Now on part C it says, suppose there were 10 marbles in the bag. Based on the outcomes, how many marbles were most likely blue? How about red? Okay, so we're going to use our experimental probability again. So remember blue, we said there were 15 out of 90 that 15 times out of 90 that blue was picked. So we're going to write that as our ratio. We're going to write kind of small because we don't have a lot of space. Okay, and now let's say we have 10 marbles in the bag. We're going to predict how many, actually using our proportion, predict how many we think might be blue out of those 10. So on here, we're going to do, I'll do the cross products, okay? And then we'll get 90x equals 150. All right, and then you divide by 90 to each side. And then you're going to get a repeating decimal. The repeating decimal is 1.6. Okay, so it doesn't always come out evenly, but we are making, we're going to round it to the nearest whole number. Since we can't have 0.6 of a marble, we're going to say that we would think that it's about 2 marbles. So an about symbol looks like a wavy equal sign. So this is about, and we'll say 2 blue. Okay, let's go ahead and box our answer. Okay, and now using proportions, we're going to also do the same thing to find about how many red marbles we think might be in the bag. So in our table, it says that red was picked 28 times. Again, we put it over 90. And there are still 10 marbles in the bag, so we put x over 10. Okay, and then we're going to do the cross products again. Okay, and then you'll get 90x equals 280. And then you divide by 90 to each side. Okay, and then it's going to be another repeating decimal, x equals 3.1 repeating. Okay, so we're going to round that to the nearest whole number. That's a 1 with a bar over it. It looks like a T, but it's actually 3.1 repeating. And so now we're going to say it's about 3 reds. We box our answer. And that's all for your notes. Thank you very much. Bye-bye.